Hi, this is Dr. K. Rajendra Prasad. I am working as professor and head for the departments of CSE Data Science and Cybersecurity. Today my topic is Predictive Parser. Predictive Parser is one of the top-down parsing technique. Here it is very important because of we have seen the last method of recursive descent parsing. We are facing one problem is backtracking problem. So recursive descent parsing, that case backtracking is required. With the backtracking, you are getting the some problem, some kind of problem. Sometimes it may not be faster. So it is one of the topic is identified in the case of recursive descent parser. So today we are discussing another parsing technique is predictive parser technique. So this predictive parser technique it requires two different algorithms. The algorithm names are called as first algorithm and also follow algorithm. Means in the given grammar prediction. The grammar prediction nothing but it defines some kind of rule. That rule is defined by that has the derivation. So in the rule we can define some kind of non-terminus and terminus. So here there is scope for defining some derivation for some possible non-terminus. So with the help of that prediction and the grammar rule we try to define what are the first and the follow values are. So here in the case of predictive parsing, first you have to know the prerequisite information is first and follow. So first and follow algorithms are very important to find the predictive parsing. So that's why today we have to discuss about these two ideas, first and follow algorithms. So what is the first algorithm is? So in the case of first algorithm, we should identify some kind of production. The production is suppose that is in the form of alpha implies E. Alpha implies E, or we can say that some non-terminal derives E. We are assuming so what is the first of E? A nothing but that is called as null value. So that means here we are defining like this. Suppose alpha implies some symbol. I am trying to giving some terminal is C and beta. So ultimately this is the first symbol. This is called as the first symbol. So in this case, this is called as the first symbol. Means specifically we should defining some kind of symbol is a null symbol that is called as the first symbol. So that's why first of alpha equal to null when nothing but it is called as the first symbol. Okay, and one more thing is suppose there is some derivation we have defined like this. Here we have the two symbols. This is the first symbol, this is the second symbol. We should define the first symbol should be terminal only. It is a terminal. So small c is always a terminal. So how can distinguish the terminals and non-terminals? Already we had some idea. Earlier classes we have discussed. So what is the terminal and non-terminal? For any particular derivation, for any particular symbol, there is some derivation. Then that is called as non-terminal. So suppose we are taking the example is A defines capital B and small a. A has a derivation. A has a derivation. That's why this symbol A symbol is called as it is one of the non-terminal. Suppose we should define in small a. Small a there is no derivation. Small a there is no derivation. It is called as terminal. So you should distinguish some symbols like that. Some symbols have the derivation, some symbols may not have the derivation. So we can distinguish the symbol which are having the derivation, those are called as non-terminals and the remaining all are called as terminal symbols. So our case is so alpha defines some C and beta. So what is the first of alpha? Nothing but you should identify the first symbol should be terminal symbol. Directly we have to getting the result is so first of alpha equal to C. First of alpha equal to C. Suppose it is not in terminal symbol. It is not a terminal symbol. It is any non-terminal symbol like A and beta. At that time, we can go for the implication is first of alpha that becomes capital A is a terminal only because A has some other derivation. the scope for getting the first symbol of the capital A is maybe terminal or non-terminal. So that's why we can recursively can call the algorithm is first of A, again first of A, like that until we have to getting the first symbol is that should be small a value. So this is I think idea of the first algorithm. So first algorithm, the name itself it defines. Okay, you try to extract the first terminal symbol. Try to extract the first terminal symbol. Suppose any other cases you are getting the, suppose it is not a terminal symbol, it is a non-terminal. It is non-terminal. At that time, recursively you can call that first algorithm for the particular non-terminal symbol also. So I am giving some examples. A becomes B and capital C. B implies C and capital D, and C implies small a B. Suppose I want to define first of A. First of A. Okay. So which is equal to, I think we should focus on right hand side the first symbol. So it is not a terminal symbol, it is a non-terminal. That's why recursively you can call again which is equal to first of B. First of B. So first of B nothing but again you have to go for what is the first symbol of the right hand side of the capital B production is. It is also non-terminal. Again you can call as first of capital C. So like that we define it. Again C has derivation. This is small a and small b. Here you should identify the first symbol is a terminal. That you write the terminal. Means you can recursively call the first, suppose when nothing but the first symbol of that particular production is non-terminal, you should recursively call the first algorithm until you have to getting the first symbol should be terminal symbol. Like that you can define these two cases, these two rules are defining itself first algorithm. So it is the idea about regard to the first algorithm. So the same thing is given in terms of algorithmic steps. Totally here we have the three different steps. These three different steps explain about the first algorithm, first of alpha algorithm. So here we can discuss what is the terminal case. X is a terminal, capital X is a terminal. First of terminal equal to the same terminal because of we are assuming this for the terminal. So it is non-terminal, again recursively you can call the first algorithm for that particular non-terminal. So you have to see the case is X is a non-terminal, like X has the maybe derivation. Because of only for the non-terminal case there is scope, we are getting the derivations. X implies y1, y2, so on, yk is a production for some k is greater equal to 1. So that case we defining what is the first of X nothing but ultimately we have to getting the first of y1. Here we have to say that first of X which is becomes first of y1. First of y1. So here we go for what the first of y1 is. Again try for finding the derivation of y1. Suppose y1 defines what? What are the symbols? Try that you have to recursively, you can apply this to first algorithm if it is a non-terminal. If it is a non-terminal, here y1 is a non-terminal. You can again recursively you can apply first of y1. So this I think idea of regard to the second step of the first algorithm. What the third step is, sometimes X is derived directly for null symbol. Epsilon there is nothing but null symbol. Null symbol purpose is so you go for reaching from one state to another state without reading of any symbol. That is the idea of null symbol. If it is a null production is there, X implies null is a production, then directly you can add null symbol to first of X. Null symbol to first of X. So you should be able to describe totally for these three steps in the case of first of algorithm. So here the very beginning step is you can define any case of first of any particular symbol equal to the same symbol nothing but if X is a terminal. X is a non-terminal, there is some production. X implies y1, y2, so on, yk. Here y1 is a non-terminal, again recursively you can call the first algorithm on y1. Nothing but first of X equal to first of y1. So after that again you can defining some kind of production is X implies it derives only for null symbol here. So first of x equal to null value only. So you should remember these three steps, okay, that are you are considered under the first of algorithm. So similarly, you can go for verify the another kind of algorithm is follow. Here the name is different. So first nothing but you should focus the first symbol of the right hand side production. The symbol is a terminal. Directly you have to go for adding the terminal symbol in the first of the particular non-terminal value. If suppose the symbol is null value, you may add null symbol also. Suppose it is a not a terminal, it is a not a null value. Okay, it is only for non-terminal. Recursively, you can apply the first algorithm on that particular non-terminal. So this is, I think, main three major ideas of the first algorithm. But what about the follow algorithm is? The follow algorithm is totally for the different. Here, as per the name, your understanding is you want to target any particular symbol for the applying of this follow algorithm. So after that symbol, what the next one is? Let's call it as a follow. Okay. Suppose I am taking the best example is A implies the B capital C small a. So I want to define, suppose the example is the follow of C. Randomly I am taking the follow of C. So follow thing, but after the C, what is symbol is small a. So follow of C nothing but you can include small a. So it means follow nothing but so your targeting is one particular symbol for applying a follow algorithm. After that symbol, what the next symbol is? If it is a terminal, directly you can add. Suppose it is not a terminal, it is a non-terminal only, then you can go for follow of capital B equal to the first of the next non-terminal. So I will explain the details of follow algorithm with the help of totally for three steps. These three steps. So here the first step is very simple. Understanding first step is very simple. In the grammar, there are many productions, there are many non-terminals, but among that you should identify the what is the first production. In the first production, what is the starting symbol is. In the case of starting or beginning symbol, by default you can include one symbol is called as a dollar. Dollar should be included. That is I given paste dollar in follow of S. When nothing but this S becomes the starting symbol. Starting the symbol in the grammar productions. So how can you identify the starting symbol in the grammar productions, sir? Suppose I am taking the production 1, production 2, production 3. That is rule 1, rule 2 and rule 3. So suppose here I am taking the A implies B and B implies C, the second production, and C production is C implies small d. C implies small d. Here, so what is the starting symbol? Nothing but A is always a starting symbol. Now I am assuming the starting symbol is A. So we assume that the S is nothing but starting symbol of a given rules. So for this example case, the starting symbol S is becomes capital A. So that case, only that starting symbol case, by default you can add the dollar, okay, in the case of follow of the particular symbol. Means I am taking follow, which is type follow of A, nothing but what the result is you can include dollar. So that is the meaning of the first rule. That is the meaning of first rule of the follow of A algorithm. So means here I am taking okay, the only thing is starting symbol in the grammar rules. So for the starting symbol, you can apply follow algorithm directly. Follow of the particular starting symbol, which is equal to dollar. So that is the major idea of the first rule. In the second rule is so if there is a production, okay, in what format is capital A implies alpha, capital B beta. Okay, capital A implies alpha, capital B beta. That case, what is the follow of B? Your focus is the follow of B. So I am taking the follow of B equal to I am saying the follow no. So B followed by what the symbol is beta. Okay, follow of B equal to, you can apply first of beta. Already you know the procedure of how can apply the first algorithm for any particular string part. Okay, so means this I think idea of the second rule. The idea of first rule is by default you can go for adding the dollar symbol. So A implies if there is a production, capital A derives alpha, capital B and beta, then fall of capital B equal to first of beta. So like that you can write fall of B equal to first of beta. I think what the first suppose some cases, okay, first of beta symbol there are many symbols. For example, okay, in any one of the example I am taking first of beta equal to, suppose I am getting the symbols, terminal symbols a, small c and also null. But you should not take null. Except null, you take remaining other symbols. Okay, that is the meaning of except null is in fall of B. So it means here I am saying the statement is follow of capital B equal to first of beta. First of beta, suppose you have considered all symbols of first of beta except null value. Except null value. So that is the meaning of the second rule. And you come to the third rule is A implies capital alpha and capital B. Capital A implies alpha and B. So here follow, if you apply the fall of capital B, okay, fall of capital B, fall of capital B. So what the fall of capital B is after no symbols. Okay, I think it may be for null. So that case, fall of capital B equal to fall of capital A, fall of capital A. So it means these are the three rules you should remember in the case of fall of algorithm. So it is, I think, is some simple idea for finding the first of and follow algorithms. Okay, so basically you follow the some three steps in the case of first algorithm and some other three steps in the case of follow algorithm. So three steps in the first algorithm is okay. It is very easy. I think again you have to revise the ideas. If x is a non-terminal, directly for first of x equal to the same non-terminal, and or suppose x is a non-terminal, but there is a scope for getting the derivation. X implies y1, y2, so on so by k. At that time, first of x equal to you can apply first of y1. And again first of y1 you can verify the derivation of y1 derivation. If it is a terminal directly you return the terminal value, otherwise recursively you can call as some other non-terminal. Okay, that non-terminal that should be first symbol of y1 production. It is the idea of the second one. And third one is if x is a null, x is defines some null value, x derives the null value. That case first of x equal to null value only. And follow. What is the follow is? So in the follow also we should follow the total for three important steps. If it is a starting symbol, means in the grammar rule, grammar thing, but it can be phrased with the help of some set of rules. In the set, for the given set of rules, you should find out where is the first production. In the first production, where you started using what non-terminal, that is called as starting symbol. In the case of starting symbol, so directly you can apply the follow algorithm, follow for the starting non-terminal equal to, directly you can write the dollar symbol. And the second one is if there is a production, A defines alpha, capital B small beta. At that time, follow for capital B equal to first of beta. However, you cannot include all symbols of first of beta. You can include all symbols of first of beta except null value. That should you remember in the case of second rule. And third rule is if there is a production, A implies alpha and capital B. At that time, I think after capital B, no other symbols. That case, what the fall of B nothing but fall of B equal to fall of A. So these are the rules of first and follow algorithm. So when you define any predictive parsing technique, because of coming cases you have determined yourself whether it is a predictive parser or not. That case is it is required, okay, to get knowledge about finding the first and follow values of the given left recursive productions. So if it is a left recursive production, again you are getting the problem. So you try to convert the left recursion to and a non-left recursive algorithm. Means without recursive free grammar productions only, we can apply the first and follow algorithms. So it is one of the example for finding the first and follow values. Here I am taking the what are the first values. I am taking on some table what are the first and what of the follow is. So you have to go for the case is one by one. First I am taking the symbol E, capital E, for the first of E. So first of E nothing but go for first of T. I am writing here first of E, okay, which is I think equal to first of T. Based upon this, again where is the first of T is here. First of T equal to you can write okay, what the next non-terminal is. First symbol of the T production is first of F. First of F. Here this is the F production. So first of F nothing but you can write the first symbol. Here fortunately the first symbol is a only for terminal symbol. Directly write the terminal value is open parenthesis. Another production case is ID. So here you can write the symbols and open parenthesis and also ID. This is a way for finding the capital E. Similarly, you can find the E dash. First of E dash. The first symbol is plus. Okay, this production. You can verify this production is first symbol is plus. And here first symbol is null. We should remember in the case of first algorithm, you may include the null values. In the follow algorithm, we cannot include the null values. And again, what the T is? First of T. First of T nothing but again here I am writing first of T. Okay, first of T, which is becomes first of F. First of F nothing but you know again the open parenthesis and also ID. Here you have the two symbols open parenthesis and also ID and also ID. And T dash. What is T dash is? Maybe for star and also null value. This for the T dash. Okay, T dash is first symbol is star. This is null. If it is a terminal, directly you can return. If it is a non-terminal, recursively you can apply the first algorithm on that particular non-terminal. And first of F, you know clearly open parenthesis and also ID. So this is a way of solving for finding the first values of the given grammar production. The grammar should be non-left recursive grammar. Non-left recursive grammar. If it is a recursive grammar, we try to eliminate that kind of recursive productions. And after that, you are getting the one final grammar that is called as a non-left recursive grammar. So simply you can go for follow. What the follow is? Follow is very important because here I am finding the what the follow of capital E is. Capital E is always starting symbol. So by default you can apply the capital E nothing but which may be for dollar. So any other case, right hand side I think here the what the follow symbol is also close parenthesis. Means I am identified only for two symbols of the follow. One is the dollar because of capital E is a starting symbol. So that's why by default you are adding the dollar. And next symbol is the right hand side you can verify there is a capital E and followed by if any terminal symbol is there. Here this case it is satisfied. Capital E followed by terminal symbol is called as some kind of a close parenthesis. Okay, I am identifying that only for these two symbols in the case of follow of E. Similarly, go for follow of E dash. So follow of E dash here. Follow of E dash equal to follow of E dash. It is okay. And any other alternative for follow of E dash is you can verify the follow of E dash is. I think we have verified the cases for the follow of E dash, right? And one more is follow of T is. There is a follow of T is. I think follow of E dash which is equal to follow of I think first of T. there is some first of t here finding. So fall of t finding first of e dash, first of e dash. So first of e dash nothing but it may be include plus common null symbol, but you can include only for the plus value only. Plus value only. And some other times I think idea no. And what is the fall of t dash is? So when you substitute t dash value is null. When you substitute t dash value is null, fall of f, fall of t dash equal to fall of f, fall of f, or fall of f equal to fall of t dash. So using some other rules, you can fill the remaining other values of the follow values. So this is a way for finding the first and follow values of the given example. So you can have given the results. What are the results here? Okay, the same table values also. Here I mentioned that these table values no. Here somewhere I think I have not filled. I'm showing the values. Okay, it is already the problem is solved. Here first of e is equal to null comma id, and first of e dash is plus comma null value, and first of t dash is star comma null value. In the similar way, fall of e equal to fall of e dash. So both are same. I think this called as here fall of e, which is equal to fall of e dash. Fall of e dash means fall of e dash also retrieving for the same values. Okay, same values of fall of e. So open parenthesis comma, close parenthesis comma dollar value, and one more is fall of t equal to fall of t dash. So what are the symbols, sir? Fall of t dash, I think the symbols you know that. Okay, fall of t, the t after that first of e dash. First of e dash case, you already know the values of first of e dash is place and also null, but you cannot take the null value only for the place, and is also include the dollar value. So finally you have to collecting place comma close parenthesis comma dollar values, which are the values of fall of t and fall of t dash. Here how you getting the fall of f is? Okay, fall of f is we go for getting the final symbols of place asterisk and close parenthesis and also dollar values. So this way you should solve the first and follow algorithms. So here I am giving some sample examples. Here for this case you can apply the first algorithm. So you do yourself the first of s. Okay, first of s, but the symbol a or b or null. So we have to write the results are a, b and null. Okay. The another case is first of s is the case I think first of t nothing but it's a small c value, and also null value can include, and I think that's enough, right? So only for c and null value, this case for first of s. So here first of t case is only for c comma null. So by you substituting this null value here, okay, what you are getting a, b and s also. That case you can add small a value also. So means first of s, you may getting the values are a, c and null. So like that you try to find the non-terminals of s, t and x. Okay, to find the first values. So similarly you go for first of s nothing but first of a nothing but small a, and first of b, what the first of b is b and c. So this case I am showing one example of this first production. So first of s, which is becomes first of a nothing but small a, and also first of b can include the first of b values is small b and c. So this way you can go for getting some better idea about the first algorithm. So similarly, I am introducing some other example problems of sample problems of the follow algorithm. Here you finding the follow, and you finding the fall of s. S is I think static symbol. No? You must include dollar symbol. Okay, you must include the dollar symbol, and you find remaining other symbols as per the steps of follow algorithm. So it means here also it is required to find what the fall of s, fall of x, and the fall of y. And this case is also some other exam, second exam also given. So with this I think you are getting some better practice about first and follow sample problems. So this kind of knowledge is required for solving the predictive parser problems. Okay, we have to see what the I think in the case of predictive parsing you are getting what the different kinds of grammars. How can defining whether it is a predictive parsing or LLF1 parsing. So we see all these details in coming class. So with this, I think we are concluding in today's class, and I'm collecting the information about these two references. One is one textbook is prescribed, that is a whole woman compiles principal techniques and tools, and some of the problems are collected from the website, that is link is defined in the second reference. So with this, thank you, and I'm concluding today class about predictive parsing.
Like, share and subscribe. Hit the bell icon for more updates.